Welcome to my Azure Kubernetes Service tutorial. So I want to make a website using wildcard DNS and have SSL and cheap, and Azure is kind of limited on the ways you can do this. Storage accounts are the cheapest static site solution that you can do, but they are limited. App services are also limited on the wildcard DNS stuff, and Azure has a bunch of new container things that are available, but I just figured I might as well go with Kubernetes. So things that you'll need to follow this: an Azure subscription, the command line for Azure, Terraform, Kubectl, Helm, and VS Code. So we're going to create a resource group. We're going to create the AKS resource. We're going to create a nginx Hello World app just to make sure that we can run something on the cluster and actually be able to access it. And then we'll create a storage account to host our static HTML just as a location for it, not to actually serve it. And then we're going to mount that storage account into nginx. Then we're going to create an ingress controller. So instead of having the base nginx as the load balancer, we'll create an actual ingress controller. And then we'll do DNS using Azure and Kubernetes. And then we'll look at TLS and GitHub Actions for continuous integration. So let's get into it. We have VS Code, and let's start with actually creating the resource group. So we'll need a Terraform file. And within here, we're going to define the providers that we're going to use. And now we need to create the resource group. So the website we're going to be creating is a knockoff on the Azure websites landing page. So if you go to any Azure websites thing, it looks like this. And I bought the domain Azure Websites spelled improperly just as a test for this. So we're going to be registering wildcard DNS so that for our website, we can go to any subdomain and get a spoof version. So we need a resource group, and that's going to look like this. So we're going to need to name it, pick a location, and let's see if we can apply this. Let's open a terminal. And init Terraform. I've aliased TF to the Terraform console. So now that we've loaded all our dependencies, we can try and apply it. Let's see if we can create the resource group. As expected, the plan wants to create one, and we'll say yes. So that worked. So if we go to Azure, we should see in a second. Yeah, so here we go. So we have our resource group. Now we need to create the actual cluster. We'll use Canada Central because the VM SKUs, there's more of them in Central than East. We'll use a pretty small VM just to keep the cost down. And we'll use a system assigned identity instead of manually assigning it. So now if we do an apply on this, it will create the cluster for us. This takes anywhere from 7 minutes to an hour and a half if you're unlucky. Azure's been kind of bad about that recently. All right, we got lucky. It only took 4 minutes. So if we look at our resource group, we should now have our cluster, and we do. So the next step is actually connecting to it using Kubectl. So if we hit connect in Azure, we get all the commands we need to run to set this up. So now we should be able to run, and it works, but we have nothing running yet. There's some default Kubernetes stuff running. For now, this is what we needed. The next step in the plan is to get a basic nginx Hello World app running. We can Helm create hello, and that'll create a template for us. We don't care about charts. We don't care about the values, and we're going to delete all the defaults actually. So the first thing that we need in our template is going to be the actual nginx instance itself. So this will create an nginx pod for us, and now we need this service to expose that. So if we deploy this now using Helm, let's actually create a script for this. So we're going to upgrade and install if it doesn't exist. We're going to install it in a namespace. We're going to create the namespace. We're going to name the deployment Azure websites, and we're going to install it from the current directory. So if we run our install script, it creates the deployment. So if we look at the Kubernetes interface in Azure, we should be able to see our new namespace, which we do, and we should be able to see the pods named front. So the pod is running, and we should be able to see the service. So we have front. It's cluster IP right now. That should be load balancer. So we can fix that by saying, so by changing it to load balancer, we will ensure that we get a public IP to access this with. So we refresh this here, pending, and now we have an IP to access our running stuff with. So we have nginx loaded. So now we want to actually change the content of our site. Let's create some content. And if we were to open this in a browser, we'll get fairly expected. It says howdy. So now we need to actually put this so that our pod uses it instead. So we can do that using a storage account. We can put the HTML file in a storage account and then mount the storage account to the pod and then have nginx read from the mount. So to do that, we need the storage account. So let's go here. So Azure storage account names are globally unique. So we'll just name it something random. Put in Canada Central because that's where our cluster is. I don't know if that matters. This is standard, and we'll do locally redundant for the replication. So that's created, so we should be able to see it now. So now we have storage account, and we should be able to see the container. No items found. So we can actually set up GitHub Actions to auto deploy our content folder whenever we make changes. So I guess we can do that. Let's go to our GitHub page. It'll help if I commit this. So let's create a git ignore. Of course, we'll not include our state files because those are sensitive. If we look in GitHub now, we should see our content folder. So now we can set up an action to update this into the storage account. So we need to log in using the Azure CLI. We'll use a service principal that we will create in a moment. Checkout. And we'll empty the contents before we add the new stuff to prevent any garbage from hanging around. So we're going to use GitHub secrets to hold the storage account name, the container name, and the service principal credentials. And then, of course, we want to log out. So this may or may not run, but it'll definitely fail because we haven't actually created the credentials that will be used. So let's work on that. And we'll actually give it a role assignment to let it touch the storage account. We'll apply, and this should create the Active Directory object and the service principal and the role assignment for us. And then we'll need to create the GitHub secrets. So if we look at the storage account now, we should see a role assignment for the service principal we just created. Perfect. So now we need to get the credentials for that and the other values into GitHub secrets. So let's create a GitHub access token so that we can do this. That should be fine. I'll regenerate this after the tutorial, so obviously don't bother. So we'll set the GitHub token environment variable so that Terraform can use it, and now we need to actually create the GitHub secrets. So we're going to create a local dictionary, so each key will become a secret, so we'll do that. Let's try that. Do init again, just in case that matters. So now we should have a secret. So if we look at the actions, oh no, I think it's settings. Secrets for actions. So now we have one called key that we just created. So now what we can do is we update this to have all the information that the GitHub Actions will need to deploy to our storage account. So now if we apply this again, we should get the old secret will be deleted, the test one, and now we'll have 3 new ones. So let's look and make sure they're there, which they are as expected. But now if we run the action again, because the secrets are present, it should work. Oof. So what happened? Please check the credentials. Perfect. So that all ran. So if we look at the storage account in the browser, you should see within the content our index file, which it is. Obviously, you could have just uploaded it manually, but we wanted this all to work. So now whenever we make a change to our content folder, it should automatically get uploaded. So that will run. And now we need to, what's the next step? We need to mount that storage account into the nginx so that when we view our application, we see our files and not the default stuff. So there's a tool for that called the blob CSI driver. So we need to make sure this is actually added, which we do by installing. Sure. Sure. We'll run this. So now that we have that, we can use it, and to use it, we go to our deployment for nginx, and we will add a volume mount. Most of this is just copied from whatever docs are on GitHub. So this will take the container name of content, and now we need to also make sure that there's a secret with a access key to that container, which I guess we could have also used an access key for uploading, but whatever. Now, so we need to create that secret. So let's do that. So what we can do is in our install script, we can get that by saying the key value to override the default in the YAML file. So we are in the deployment, we're referencing a container storage, and the secret uses storage account name and key. So we can actually set the storage account name to that. And then the key gets overwritten when we actually install it. So let's see if that works. We go into our hello and run our install scripts. That should update to include, oh, indented wrong. So now if we describe this pod, we should see somewhere the volume mount, which we do. So that just makes the volume available, but now we need to actually mount it. And we'll name it the same as the volume that we just made available. So if we do that, then now we have our HTML files. And if we go /beans, we have our beans file as well that got deployed. So we have that working, and now we need to get DNS working. So we'll create a Azure DNS resource. If we look in Azure, we should have a DNS zone. Perfect. So now we need to actually set this up to be used by the domain so we need the name registrar to point to it properly. So inside Namecheap, you can set the custom DNS to the values in Azure. So we'll just copy these, make sure they're all the same. And then there'll usually be a check mark or something if you made any changes, but it's all the same. So now this will be used when doing name resolution for our domain. So if we did azurewebsites.net, that was cached. Then it's still not working, obviously, because we don't actually have any records pointing to our site. So we can have Kubernetes automatically create records for this using a tool called external DNS. So let's go set that up. For it to be authenticated to make changes to our DNS zone, there's a few ways you can do it using service principals or whatever, but the Kubernetes cluster itself gets a principal and we can give that permission. So inside our DNS Terraform file, so let's make sure that role assignment gets created properly. And if we look at Azure, we should see the role assignment now. And we do. So that's the cluster's agent pool identity. There's a few others that get created, I guess. But for now, this should work. So we need to install external DNS. So we need to get the cluster identity and set that in a few places. So this should be everything we need to create external DNS in its own namespace using our DNS zone and using the managed identity for the cluster. So the inverse of this is create an uninstall. Should just be deleting it using Helm and also deleting the namespace. So this will take for our ingress, will automatically create DNS entries for that. So I suppose we actually need an ingress controller now. So let's set up an ingress controller, I guess. And the uninstall will be very similar. So now we should have the nginx-ingress controller available. So if we look at the cluster and services, we have the ingress controller, which has its own IP. And now we need to change our service from a load balancer to being a cluster IP and then creating a service or an ingress for the service. So let's do that. So we just go to hello, we'll change our service, we'll just comment out that, and now we need the ingress. So this will create an ingress for our Azure Websites thing named front. We're going to have two hosts, one for all the subdomains and one for the Apex domain. Those will all be running on port 80 because we'll do SSL termination with the ingress controller. So now we just deploy this. Look over here, this should be no more. And we should have an ingress for it. And it has both the hosts. Because we configured the external DNS, it should, in theory, recognize that we have these domains, and we'll go over here to the DNS zone, and we'll actually create records for them, assuming nothing has gone wrong. Yep, so it just took a moment, but now we have star and Apex paths for our ingress. And if we load our website, we'll get a warning about self-signed certs. Yeah, but we have our thing working. So now the next step is getting proper certificates. And there's another tool for that called what, cert-manager? Yeah. So you can actually run it without the self-signed certs if you change a value somewhere, but let's just not even worry about that and get those certificates working. So we need to install cert-manager, so let's do that. So we'll create values to customize the install. So we'll say install custom resource definitions, yes. And we need to pass in some extra args to allow it to use the managed identity. So for the challenge, to make sure to tell Let's Encrypt that we actually own the domain, we need to give cert-manager permission to use the managed identity to modify our DNS zone. Because we have an Apex domain, we can't use HTTP challenges, so we have to use DNS challenges. So this should be enough to install cert-manager. So now we need to actually create the issuer for our domain to tell cert-manager that we want to use Let's Encrypt for this. And now we need to modify our install script to make sure these values are set properly. So we can actually copy some of the values from here. So this grabs the resource group name, the managed identity of the cluster, and the tenant and stuff. So now we just need to set them. We'll overwrite with the proper values. So that'll create the issuer. So we can install that. So now we can get the issuer. And we should see it there. And we can describe it. Failed to register. Oh, this should be directory, not dictionary. Yeah, so now that worked. So let's actually set up our domain to get a cert. So if we go to our ingress, then here we can say to use an issuer. So we created our staging one, and then we need to tell it to use TLS, and the hosts will include all the subdomains and the root. By applying this, that should tell cert-manager that we want to get a certificate. So now it's going to create this cert. So it's going to create the cert, and now the cert is going to create a certificate request. So that was approved but not ready. So let's find out why. So it's creating an order. And that order is pending. So it's creating a challenge for the domain azurewebsites.net. And what does it say? Pending, yada, yada, yada. So it should be creating a DNS entry to prove that we own the domain. And then that will let Let's Encrypt know that it's okay to issue us a certificate. So one pending, one valid. So what is the pending one? Waiting for the challenge. Yeah, so as expected, it's just waiting for the DNS to be acknowledged by Let's Encrypt. I guess that challenge got removed because it's probably done by now. So let's describe the certificate itself has been successfully issued. So if we go to our domain now, let's look at the cert. View certificate. So it's from staging. So the Let's Encrypt, it's because of staging, it's like not well known. So it's saying it's still a security risk. So now that that's working, let's do it all again, but for Let's Encrypt prod. So we can just copy and paste staging, and we actually just remove that. So now we have an issuer called Let's Encrypt prod with a different private key. And now we can go over here and change in the ingress to prod and do it all again. Yeah, the auto formatting totally misbehaved here. Let's try that again. So now we have the request for Let's Encrypt prod. And with the request comes an order, I think. And then with the order gets a challenge. Verified. 0 seconds ago. All right. So now it's on the second challenge. There we go, verified. So if we go to here and refresh, we now have a proper certificate from Let's Encrypt on our domain. So let's look at our checklist. What do? We created a resource group, created AKS, did a hello world, created a storage account, mounted it, ingress controller, we have DNS working, we have TLS working, and we have GitHub Actions. So that's how you over-engineer a static website. And if we also go to any subdomain, this also serves our site, just as the actual Azure websites thing that we are spoofing. This is what it usually looks like, and you can put in MEC. And now, whenever people make a typo, they will get hit to my site instead. Wonderful. I'll try and put some links in the description, but apparently ArgoCD makes a lot of this easier, but I have no idea how that works, so may or may not look into that for the future.